All right, so 1 and 2 are calculators, 3, 4, 5, and 6 are non-calculators. So let's read this one, see what they gave us. This is the graph of f prime, and typically that is what they give you. Are you already thinking sticky note? That's going to be on here somewhere. Like that is typically when they give you the graph of the derivative, that's going to probably be on here somewhere. They also give you an initial condition. Do you see that? F of 4 equals 3. Your accumulation does not start at 0. It starts at 4. So just be careful. It's whatever they tell you. And our interval is from 0 to 7, semicircle and line segments. So we're all good. Find f of 0 and f of 5. All right, so letter A, f of 0, it is going to be 3 plus, where did I get that 3 from? Good, 3 plus integral from where to where? Well, 4 to 0. Why does it start at 4? Kind of because it says so. And why does it end at 0? Kind of because it says so. All right. And then the derivative is what goes in there. Here, we'll come back to that. Let's try and set up the other one. F of 5 is going to be 3 plus integral 5 of f prime of x dx. I believe that was worth a point. Let me see. Yeah, writing out like this integral here was worth a point. So if you even did it once, you got a point for that, right? So let's go back and do 0. That's going to be 3 plus, all right, we want to accumulate from 4 to 0. Now that's going backwards. Do you see that there? How much is this semicircle worth? We've done like a gazillion semicircles. But it'll actually be negative 2 pi because it's below sea level, but since we're going backwards, it will actually be 2 pi. So 3 plus 2 pi, you get a point for that. And then this one is going to be 3 plus integral from 4 to 5. That's this little guy right here, this little triangle. How much is that one worth, this area? 1/2. So 3.5, and you get a point for that. All right, letter B. Find the x coordinates of all points of inflection. Here it is. This is your sticky note thing. How do you get a point of inflection from your derivative graph? It's where the derivative changes from what to what? Increasing to decreasing, or, and there's not a shorter way to write that, okay? So where are they? X equals what? 2 is one of them, good. I heard somebody say that, and 6, good. X equals 2 and x equals 6, you get a point for saying that. Because f prime changes from increasing to decreasing or decreasing to increasing there. And you get a point for that explanation. And no, there's not a shorter way to put that. I'm sorry, I asked, they told me write that. I was like, fine, right? Just do it. It'll get you the point.
If you said and before, would that be wrong?
Right there,
Yeah.
you have to say or. Because it's one or the other. You can be even pickier. I wouldn't do this because it takes longer, but you could say x equals 2 because f prime changes from decreasing to increasing there, and then separately say x equals 6 because f prime changes from increasing to decreasing there. Do you get what I'm saying? But like way wordier. So, I mean, it's a timed exam, so I try to tell you the most succinct way to put everything. All right, let G be this thing, f of x minus x. On what intervals, if any, is G decreasing? What would you need to find to do increasing or decreasing? It's G prime, but you are correct. All right, so we're going to find G prime. So what is the derivative of this thing? How would you write that? It would be f prime minus 1. I think that was a point. Oh, if you got that, you got a point. So even if you didn't make it any further, you got a point for that. Now you need your critical points. So you would need to set this equal to 0. So let me just shimmy that in there. If you set that equal to 0, you would add over the 1. And so we're looking for where f prime equals 1. Now I drew all over this picture, so let me erase this and show you. Because this is the graph of f prime, right? If I do f prime equals 1, where are my critical points? Where does this intersect? 5 and 7. And we want to know on what intervals is g decreasing. So I'm going to tell you where and see if you can give me the reason. G of x is decreasing from 0 to 5. Do you see this section right here? And it would be because, who's your source that you cite? G prime is decreasing means negative there. That was a horrible there, but anyway, point for that. Why did I pick from 0 to 5? Yeah, do you see how you're below sea level just shifted a little bit? So this is now you're below sea level, and then from 5 to 7 is you're above sea level. Do you see that? Like it just moved. It changes where, yes, perfect. It changes the 0. It changes where 0 is all that happened there. All right, and then letter D. For the function g that we just used, find the absolute minimum. Absolute maximums and minimums are what test? All right, so you're gonna put x, g of x. Your candidates are end points and critical points. So that's 0 and 7 are your end points. And then where's the other one? 5. Remember how it got shifted up? It's not 4, it's 5. All right. Now, good news, if you identified those candidates, you get a point. And then it's 1 point for filling out the rest of the table and saying which one is the smallest. Now you catch a break on 0 and 5. Because what was G? Look back at the problem. G is f of x minus x. If you read back through there, you see that. We did f of 0 back in part A. I bent my paper over so that I could, fit this on the screen here. But can you guys look back? What did we get for f of 0 back from part A? Okay, so it's going to be 3 plus 2 pi for this part. That part that I'm circling right there, that's the 3 plus 2 pi minus what's x? 0. So it's 3 plus 2 pi minus 0. That is approximately 9. If you think of pi as being 3, 3 times 2 is 6, plus 3 is 9, approximately. All right, oh. No, I just do that because you have to, at the end, figure out which is the biggest and smallest. And when it's written in pi, it's like, you're like, what on earth is going on? All right, what was 5 from part A? 3.5. That's this part. And then it's minus x, which is 5. So 3.5 minus 5, negative 1.5. Now, womp, we didn't already do 7. So we got to go back and get 7. What was your initial condition? 3 plus integral from 4 to 7, f prime of x dx. I'm going to be lazy and not write that. Okay. So that would be 3 plus. All right. We need to accumulate area from 4 to 7. That is all of this. So I would break it into this triangle. How much is this triangle worth? 2. And then we have a trapezoid. Or you could do a square and a triangle. Would that be 1.5 plus 1.5? Good. Minus 7. Why am I doing minus 7? It's the minus the x value. Okay, so let's sort that out. What does that all come out to? So what is that? 6.5 minus 7, so negative a half. And I think they wanted minimum, right? Was it? I always forget whether it was maximum or minimum. All right, so your absolute minimum is negative 1.5 at x equals 5. All of that was worth a point. The explanation and the justification, which is the chart, and then the answer. Let's go through that and realistically see which ones we could have gotten. I feel like part B should be gimme, right? Those two. I feel like if you calmed down long enough to even write f prime minus 1 for this, you would get that one. Okay. And then I think if you even identified the candidates, you would get that one. So that'd be 4 out of the 9, which is okay. All right. Even if you skipped all that really hard stuff. All right, let's see if, we have enough time. I'm going to be able to do it. So we're going to do number 4 as well. My goal was to do 2 per day. So I think we'll be able to do it. All right. So this is number 4. We have a table. An ice sculpture is melting. Did you say, well, I mean, that's what ice sculptures do. You are given the rate at which it's not, oh, per day, it's lasting a long time. It's a cone that's decreasing in size. This is the rate of change of the radius of it. We have centimeters and we have days from zero, lasted 12 days, 0 to 12 days. All right, approximate the second derivative for 8.5. Now this is already a derivative and we want to get a second derivative. You would do a slope. Now, which points? Because it says 8.5. 8.5 is in between those. Do not be too proud to write these out. If you mess it up, you're going to be upset. Write the points. And I saw a lot of you did that on your mock exam, so good job. Because there was one just like that. So then slope them. It would be negative 3.8 and then what? Plus 4.4 over 10 minus 7. Do not write 3, write 10 minus 7 because they like the show how you got your answer stuff. What does it say? Yeah, there it is. Show the computations that lead to your answer. If you write 3 instead of 10 minus 7, they will not give it to you. All right. It's a point for that. And then it says, what else? Indicate units of measure. It's going to be a point for the units. So if this is in centimeters per day, our units are centimeters per day squared. It's a point for that. So 2 points for that. All right, letter B. Is there a time, yes or no, from 0 to 3 where the derivative equals -6? It's either going to be mean value theorem or intermediate value theorem. So let's look from 0 to 3. We're just looking at that part. Does this R prime have to equal -6 somewhere in there? The answer is yes. And which theorem is it? Intermediate, because -6 is going to be in. Good job. Perfect. Nice job. All right. So we're going to say yes. Since, oh, does it say differentiable? This is usually what they do. But yep. So since, oh, yeah, I think we can just say since R prime is differentiable. Let's practice writing out the whole word because I don't think they'll take diff. I let you do that, but I don't think they're going to. Since R prime is differentiable, it is continuous. And then you have to say in some capacity that -6 is between these other two values. This is the simplest way to do it. And I looked back through the scoring guideline for this one, and this test was only 2 years ago. This is the 2022. That's actually all you had to say. And they gave you a point for putting this and a point for saying yes and the rest of this explanation in some capacity. I was like, oh, wow, my kids can do that. But it says if you reference an incorrect theorem, then they don't give it to you. But, well, see, but I have seen scoring guidelines where they do want to see that. You know what I mean? Like sometimes they want it and sometimes they don't. But this was only 2 years ago and I went through it with a fine tooth comb and that's what it said. So I'm just throwing it out there for you. I would say probably don't reference it. If I had to pick one or the other, because if you reference it wrong, they're not going to like it. Okay. All right, part C. Use a right Riemann sum with the 4 subintervals in the table to find that. So I would circle them 1, 2, 3, 4. And it was a right sum. Off we go. What would you put first? 3 times -5. Good. Plus 4 times -4.4 plus 3 -3.8 plus 2 times -3.5. That's worth 2. They say it's 1 point for the format, which just means something times something plus something times something, like the format is right. And then a point for it being a right sum, like all the correct numbers. But that's 2. And actually, I don't think we had to do anything else for that, did we? Does it say anything else? No. Now, I'm going to say this on the recording as well. I haven't run across one of these recently, but sometimes they do this. They will want the absolute value of that. And you would have to turn all these numbers positive, which is very easy to do, but also very easy to forget to do. So just be aware of that. All right. Last one. The height of the cone decreases 2 centimeters per day. How would we label that? Height is decreasing. DH, you guys are gonna eat this test up. All right, and it would be what? -2. Perfect. I'm not gonna worry about units right now. Well, unless it says indicate units of measure, I'm not gonna worry about them. All right. At time 3 days, radius is 100 centimeters. So radius is 100. Didn't say a rate, it just said the radius. And height is 50. Find the rate of change of the volume. So what's our question mark value? dV dt, and it should be negative. Why? Yeah, it's melting, right? Getting smaller. So that's what we're looking for. Do they tell us anything else? Yeah, time is 3 days. That's not really going to come into play here. They're just throwing that at you. And then they do give you the formula, so that's great. All right, so volume is 1/3 pi r squared h. Which rule are you going to need for that derivative? It is product. Good job. Product rule. 1/3 pi r squared is the first thing. H is the second thing. So write kind of small. This is gonna get very long horizontally. All right. So it's gonna be the first thing, 1/3 pi r squared times dH dt. Perfect. Plus H, the second thing. Now, if you bring down, yeah, every time you do a dt thing, that's a chain rule. If you bring this 2 down, it'll be 2/3 pi r to the first, if you want to put the little 1 in. I always think it's weird when it's a 2 and it changes to a 1. All right. And then dr dt. Perfect. Let me see what that, oh, that was 2. The product rule was 2. And I'm sure it said, I don't remember this one as clearly, but it was probably 1 for the format of doing a product rule and then a point for it all, being correct. So like if you forgot that dr dt, they would give you 1 out of the 2. All right, so you always write something. All right, now let's plug everything in. 1/3 pi, what is r? All right, so 100 squared times dH dt, which is -2. Plus, what's height? 50 times, I'm gonna run out of room. 2/3 pi, r is 100. Now, you do have dr dt, it is somewhere on there. They cannot give you an undoable problem. So look back through, think about what dr dt means. It's the rate of change for r. Why is it -5? Because that is correct. Where'd she get that from? The table. And why is it the -5? It's at time 3 days. So that's where the -5 is. And what should you do to all this? Absolutely nothing. That is worth a point. It is your grader's job to sort through that and figure out if that's right. It is not your job. You write it as neatly as you can and then move on. Okay?